Welcome to the Cobra tutorial. In this tutorial, we will explain how to correctly assemble Cobra tree cabling. Cobra is perfectly suited for a great many styles of supplemental tree support and can be considered for virtually any tree species, size, or shape. And most uniquely, Cobra can be installed to deliver a lot of elasticity to very little. With Cobra, you are always on the right track because tree installations meet technical requirements of the American ANSI A300 and German ZTV standards. Retains 12 years of rated tensile strength thanks to UV-stabilized materials. Is not harmful to trees. Can be comfortably adapted to a variety of tree structures. Offers shock absorbency through an integrated absorber component. Grows with the tree thanks to an innovative use of material. And finally, Cobra leaves a gentle reminder that customers' trees are being protected by the very best. Here we can see Martina on her way up a tree to be cabled. While she's ascending to her work position to install a Cobra system, we'll take a closer look at the individual components and installation types of the Cobra systems. These are the individual components of the different Cobra systems. The cable is woven from polypropylene monofilament, are incredibly strong and yet comfortable to handle thanks to the soft meshed braiding. Expansion inserts flatten the contact area to reduce load pressure that might otherwise lead to girdling. Anti-abrasion hose allows the rope to slide freely around the connection point. End caps serve as a colored identification of the installation year. The shock absorber is a key feature for Cobra installations. One or more shock absorbers can be installed with a Cobra span to dramatically reduce impact forces known to break steel wires or shatter cabled limbs. Apart from rope diameter and strength, the components of 2 and 4 ton Cobra are identical, while the size and strength of 8-ton Cobra are greater, all of which are 4 to 8 times stronger than the most common means of securing wire, by using inch J-lags. Very few tools are required for assembling Cobra. The only thing you need is a pair of scissors to cut the rope and anti-abrasion hose and a heat torch to shrink the end cap. Before we take a look at how the Cobra is assembled, we would like to quickly explain the installation methods for Cobra. In short, there are 2 different installation methods: shock absorbing or non-shock absorbing. Shock absorbing installations are designed to prevent a sound crotch from splitting, while non-shock absorbing installations are intended to minimize strain to limbs predisposed to injure or unions with included bark. Shock absorbing installations are assembled in the 2/3 region of the crown to make optimal use of the leverage effect. There are 2 different types of breakage cabling, dynamic and static. These installations are the standard type used for Cobra. They restrict excessive swinging motion and disrupt wind loads between branches to help support the crotch below. The Cobra model chosen is dependent on the base diameter of the branch to be cabled. The Cobra 2T can be used for base diameters up to 16 inches, 4T for those branch bases up to 24 inches, and the Cobra 8T for diameters up to 32 inches, again measured at the branch base. Non-shock absorbing installations more intently restrict independent movement of involved branch parts to prevent a weak crotch from opening or reopening. The necessary systems for this include Cobra 4T for diameters up to 16 inches, 8T for those up to 24 inches, and Cobra 8T doubled up for diameters up to 32 inches. Martina has now reached her final position, has prepared the Cobra material, and will now demonstrate the assembly process. First, select the correct length of expansion insert. This should be at least 2/3 of the branch diameter. Grasp the cable at a distance the length of the expansion insert plus 16 inches and feed the insert toward cable end. You should now be able to hold the expansion insert from outside the rope while milking the rope slack over it. This simple process takes only a little practice to memorize for life. If you find yourself struggling, ease up. You're trying too hard. Next, determine the length of the anti-abrasion hose, which should be at least the diameter of the stem to account for future growth. Cut the anti-friction hose and feed the cable inside it. Next, place the cobra cable around the branch and begin to splice it. Once finished, the splice itself should reside away from the branch and not tight against the stem. Grasp the rope, open the mesh, push the end approximately 16 inches for 2-ton or 20 inches for 8T cobra inside the rope and then pull it back out. These measurements need not be exact as long as they are not shorter than prescribed in the instructions that accompany cobra. Check once again that the splice is not tight up against the tree, but out from the stem as Martina displays here. Next, feed the end back inside the rope a few inches past the previous exit point. Work it through the rope 6 inches and then pull the end of the rope out so that the heat shrink cap is visible. Note the reserve loop remaining for future stem growth. Next, grasp the rope beyond the splice and insert the shock absorber. Check the final cable path to ensure that the rope will not be rubbing against other branches. After repositioning to the opposing stem, tension the cobra rope in order to find the subsequent position of the expansion insert. Here, insert the expansion insert into the cable. Before cutting the cable to length, place it around the branch, form an imaginary splice and growth reserve loop and cut the cable at this point. Then slip on and heat shrink an end cap of the appropriate year. You can write on this if necessary. Next, cut the anti-abrasion hose to length as described before and position it on the cable. Finish by creating a splice and a growth reserve loop as performed around the first branch. Tension the cabling so that it is only slightly slack. In winter, cobra is mounted with more slack in order to avoid continuous tension brought on by the weight of summer foliage. Now, tighten the cobra cabling by hanging or standing on it. In this way, you can ensure that all parts are firmly interlocked. You can cable 3 or more branches very effectively with all sizes of cobra. In this display, the wind load is shifted from the weak branch to a stronger one, and the swaying motion is restricted so as to prevent the branch from breaking in strong winds. However, cobra does not prevent the tree from swaying naturally in light winds. In this image, you can see the cross-section of a triangular bracing. This is an ideal solution, as it can restrict excessive wind load in all directions. In certain situations, it is only desirable to brace a tree from near imminent failure. In this case, you should assemble the cobra without the shock absorbers and as vertical as possible. In this way, the branch will be held in place directly following breakage and with as little distance for shock loading forces as mechanically possible. The necessary breakage load of the system is dependent on the weight of the branch. As an estimate, you can use the basic diameter of the branch to be restrained. The Cobra 2T can be used for diameters up to 12 inches, the Cobra 4T for those up to 16 inches, the Cobra 8T for those up to 24 inches. Cobra 8T can be doubled up for diameters up to 32 inches at the branch base. Please ensure that the abutment is sufficiently stable at all times. The assembly processes for horizontal installations are carried out in the same way as just explained, that is, without shock absorbers and as taut as possible by hand. Please ensure that the cable orientation runs as vertically as possible and that the cabling is tensioned. In this way, you will prevent the branch from falling into loose cable upon breakage that would cause additional impact forces to the supporting abutment. We hope that our tutorial has given you a comprehensive insight into our products and their use. We wish you every success with your own Cobra tree cablings. Supplemental tree support and bracing are advanced practices within arboriculture services that require a developed understanding of wind, ice, and tree dynamics. Cabling without education or apprenticeship on these subjects can be harmful to trees, people, and property. Find out more by visiting the International Society of Arboriculture ISA website, www.isa-arbor.com, or by calling 888-472-8733.